This video is a demo of a proof-of-concept application of stream mining techniques to churn prediction. The project is a collaboration of Ericsson Research with UPC Barcelona Tech. The goal of the project was to demonstrate the potential of stream mining techniques for adaptively extracting and applying knowledge in highly changing scenarios, and in particular the advantages over more standard data mining techniques. There is a companion PowerPoint presentation to this video. It is recommended that you view it before watching this video. In short, the program simulates a number of virtual subscribers. Subscribers have a number of internal features, sex, age, income, etc., that influence their individual behavior, together with the parameters that we can change during the execution. But subscribers are probabilistic, so we can only predict approximately what they are going to do. Over time, a subscriber moves back and forth between two companies. We will call these two companies our company and the competition. The application comes as two jar files. The server, which uses more resources, and the lighter one for the client or interface. They may be run on different machines and connect via sockets. In this case, we will run both of them on the same computer. So we start the server, which runs in the background, and now we start the client, and we see the main screen. It is divided into areas. On the left, we can set parameters controlling the simulation. On the right, we see the results of the execution. There are 4 tabs, which we will explain later. Right now, we are seeing the one that will report statistics about events processed and predictive accuracy. Here we can set the number of simulated subscribers. We leave it to the default 1000 and say that initially they are split half and half between us and the competition. Let's start the simulation now and slow it down so that we can see more clearly what is going on. Subscribers start producing what we call events. Here we see their counts, number of calls, number of bills emitted, number of complaints filed by the subscribers, number of subscribers that have churned, that is changed company, and number of subscribers that have subscribed to our company. Some of the events trigger a prediction about churning. For example, every time a subscriber complains, we will evaluate him for the churning probability, and when he gets a bill, and when he calls, at most once per call per day. Each evaluation creates what we call a record, and when a customer actually churns, we generate a churn record. Here we see the daily churn rate, that is the percentage of customers that change company every day, which is about 1% right now. Here is the percentage of subscribers currently in our company. We started at 50% and we have not changed the parameters from the neutral initial setting. So there are roughly as many customers churning in one direction as in the other, and our share should fluctuate around 50%. Here we see statistics about how accurate we are being at predicting churn. Accuracy is simply how often we are correct in our guess. That is, we predict that a customer will churn, and he does, or that he will not churn, and he doesn't. All predictions are made with a fixed horizon of 1 month in our case. 2 related very important statistics are called recall and precision. Recall is the percentage of actual churn events that we predicted in advance. We want high recall, that is, to predict most of the cases of churning before they happen. Precision, on the other hand, is how often when we predict that someone is going to churn, he really churns. If our precision is low, we will have a lot of false alarms, thinking that many customers are going to churn and then they don't. In the plot, we see the evolution of recall in blue and precision in red over time. We admit that these figures are probably pretty high, higher than we can get in real scenarios. They are meant for illustration, and in fact they basically reflect how predictable we made our synthetic data generator. On the other hand, let me emphasize that the predictor starts as a blank slate. It has no knowledge whatsoever initially of how to tell that someone is going to churn, and is learning everything from scratch from the behavior that it sees. Let us change the situation a bit. For example, let us say that for some reason the competition suddenly becomes more attractive. more of our customers should now be churning to the competition in the next few weeks. We see that recall and precision have a sudden dip because the rules that we had so far for prediction of churning are not valid anymore, or at least they are not so accurate. But see, in a short time, the blue and red lines start going up again to levels similar to the ones before. The predictor is learning from recent experience and changing the prediction rules to make them accurate again in the new situation. See the yellow and green lines? These are the figures that we get if we keep applying the rules we had before the change. If we stick to the old rules and not train them with new data, we perform worse and worse instead of catching up as with the model that adapts in all times. In this case, precision goes down a little bit, the green line, but we have a very substantial drop in recall. It could go the other way around. And this is the key point about stream mining. The difference among the plots is what we would be losing if we used the traditional data mining techniques, where the prediction rules are not updated immediately. For example, they need for human recalibration. Here we are immediately reacting to change. Note also that the percentage of customers in our company has gone down substantially from 50%. There are more customers moving away from our company than into it, or we are losing market share. Now let us change some other parameter. Say that we counterattack by offering better service. So the complaint rate goes down. See again, the predictive power of our system has gone down temporarily for a little while. But the new model catches up soon to previous level, while the performance of those that got frozen will degrade quickly as soon as customers start behaving in the long term with the new rules. Also, we should see that the number of users in our company has gone down a little bit. Let us move to the Business Value tab. The goal of this tab is to see the connection between our ability to predict churn and the actions aimed at retaining customers. What will happen in a real case is that the predictions about potential churners will be passed to some other subsystem that will perform actions to try to retain them, either automatically, such as sending them a text message, or via a human operator. For example, we might offer them lower rates or a discount on a flashy new terminal. With this slide, we control the cost of these actions when they are accepted. For example, the value of the discount that we offer. Customers may accept this offer or not. With these slides, we can change the probability that they accept. For simplicity, we have assumed that all customers accept with the same probability. Here, the blue line indicates the daily cost of retention. The red line indicates the daily cost of the retention actions we perform, and the blue line the income that can be attributed to these actions. So the difference among the two is the benefit obtained by using the churn prediction system. To have a high difference, of course, it is crucial to have good recall and good precision, so that we catch many churners before they leave, but also that we do not offer too many discounts to customers that are not going to leave us. Very briefly, let us describe the Profiles tab. A churn prediction tool with high accuracy may be great money-wise, but is more useful if it can tell the human analysts why churn is happening. This tab is meant to illustrate that many stream mining techniques can in fact explain how they are predicting churn by producing profiles of the customers that churn and those that do not. For example, describing them by means of features common to each profile. In our case, our prediction method is called an adaptive halving tree. It is a kind of decision tree, and it is fairly easy to obtain these profiles from this decision tree. The profiles would be shown here. Again, in this proof of concept, the profiles are not necessarily those that we would obtain in a real scenario, but in fact those that we built into our synthetic data generator. There is of course an About tab that simply tells who worked on the project. Feel free to contact me, Ricard Gavaldà, or David Manzano at Ericsson Research for more information. We hope that we have illustrated the potential of stream mining techniques for highly changing scenarios, mainly their ability to quickly and autonomously react to changes in the data, adapting to new situations with little human intervention. This is in contrast to more traditional data mining techniques which require much more supervision. Also, the application to churn prediction is one of many potential application scenarios. We have elaborated on 3 of them: transportation, mobility and energy, in a report within the same collaboration. Thank you for your attention.